All right, thank you, Eliska. So, yeah, my name is Allard Buijze, and I'm the founder and CTO of Axonic. Some of you might have heard of Axonic, some of you might not have. Axonic is a new company that we founded on July 1st this year to basically take over and continue the development of the open source Axon framework, as well as some additional add-ons that we're building at the moment, and providing support and training and everything related. So the company is really focused around everything that has to do with Axon framework. I did a webinar similar to this one about a year ago while I was CTO at Trifork. That version was based on a pre-release of Axon 3. In this webinar, I'm going to show some of the new features of Axon 3.1 as well. Not all of them. There's the release was a bit too big to do that, but more importantly, we're just going to get started building an application and then scale it out. Well, this is the plan. I'm going to do a short walkthrough of the chat application. There's some code prepared for this, which you can download yourself as well. And there's a README file with a few exercises that you could do, or you can sneak peek into the solutions branch and copy everything from there. We're going to see how the given when then fixtures work and how we can use them to describe tests for mainly our aggregates. We're going to, or I'm going to implement an aggregate and the command handling features there. We'll implement a view model as well. And then the most important part is we're going to scale out, and we're going to do that without having to change any of the business logic code that we have written earlier. So this is the plan. It's the live coding session. Even though it's recorded, the recording was live. So things never go according to plan, but let's see how far we get. So as I say, you can try this out yourself. You can go to the GitHub page of Axonic. You'll find an Axon Quick Start repository there. You can clone it or fork it, whichever you like. And there's a README file describing some of the exercises you can do. Basically, that's what I did as well. So let me move to the workspace. So this is the application you get once you've checked it out. And it contains two modules, the chat getting started and the chat scaling out, and that's exactly the two phases in this webinar that we're going to have a look at. But just to prevent you to have to implement everything to figure out how you scale things out, there's the essentially the solution of the getting started is where you start with the scaling out part. So if we look at this module, the chat getting started is an application in itself. It's a very simple application, nothing too fancy in terms of functionality. It's a chat application where you can create a room. Participants can join the room and then chat with each other. We don't have a full-fledged UI for it. That's not the goal of this webinar. But it does work with a proper API. So the application, it's a Spring Boot application. So there's the necessary annotations and a bit of code. There's some Swagger configuration here. We're not going to use any of it, but if you go to the Swagger URL, was it /Swagger API, something like that, then you get all the documentation automatically. Then we have a package structure where we have the command model in the command model package. Right now, that's our chat room. It's completely empty. The class is just there so that the code compiles, nothing more. And we can run our test case, and obviously everything will fail. Then we have a core API package, which contains the messages that we can send or that the application can send. And we've described this in Kotlin. Partly just because we can, but also because it's a very concise way to describe our commands and events. So instead of having a file per class, we can now have a single file that describes all the commands and events that are very tightly related to each other. So you can see here a data class for the create room command contains a room ID, which is a string, and a name, which is a string. That's how we create a room. And then we have the event, which also has the room ID and a name. We can join the room, and we get a participant joined room. We can post messages, and then we can leave the room. Very simple, but it contains the features that we need to be able to scale. Then on the query side, there's an events controller here. This is just to get a sneak peek into what's stored in the event store, and we can have a look at that later. So it's a rather technical thing, not so much has nothing to do with a chat room per se. And then we have a number of view models, and this is the essence of CQRS, in fact. So even though we have a single chat room, there's different ways of looking at chat rooms, and one of them is show me the messages in a chat room. So we have a chat message projection, which is not implemented, but there's a get mapping for it. We can go to /room ID/messages to get a list, or in this case, a page of all the messages that have been posted on that room. We'll dive into more details later. We can also have a look at what are the participants in the room. That's a different view, a different way of looking at rooms. So we have a projection here that gives us all the participants that are currently present in the room. And lastly, we have a summary which gives us a list of all the rooms with the number of participants in that room. So when you want to decide to join a room, you can decide on whether I want to join a full room or an almost empty one. Pretty simple, but obviously nothing really works at the moment. And then we have the test cases. And in the test cases, you can see we use the aggregate test fixture here. I've decided not to implement this while typing because it's pretty verbose to type everything written here. This describes a number of test cases that we expect to work. So we want to be able to create a room. So given nothing happened in the past, when I create a room, I expect the room to be created. And that's not really fancy logic, right? This is something you can safely assume in any system. However, there are situations, if we move a bit down, you cannot join a chat room twice, for example. So we say, given we've created a room with a certain ID and a certain name, when a participant joined that room, has joined that room, so we've got a room that has a participant that joined in the past. If we join again if we send a command to join that room again for the same participant, we expect that the handler was successfully executed, so we expect no exception, but we don't expect any events either because nothing really happened. We're just saying that command is okay, but we're not really doing anything. And of course, it's the same for leaving the chat room. If you've left the chat room, you can describe that we expect the participant to, well, he's still gone, so nothing really happened. It's okay to send the command. However, when we say we want a participant, we want to prevent a participant from posting messages to a room he did not join, in this case, we want to fail such a command with an exception. So we want to say, if we have created a room and a participant joined and then a participant left, when we post a message on behalf of that participant to that room, it's an illegal state exception. In real life, you would create your own exceptions and not reuse the rather generic exceptions by the JVM, but this is good for now. So we expect no events, but we also expect an exception. And these are different ways to handle failure. So the nice thing about these test fixtures is that we describe everything using these functional events and commands. There's no tight coupling to the business logic involved at all. The only thing that we have needed and we need to refer to is the class of the aggregate that we're trying to test in this case. The fixture will create all the necessary plumbing that you need to be able to execute logic on that aggregate based on the commands and the events that you described below. So as you had seen earlier, the chat room class itself is completely empty. And that's something we're going to have to change, because once we run these tests, well, you can safely assume they will fail. There you go. Plenty of mistakes. There's no handler for the command. That's correct, because we're sending a command, but Axon cannot find a handler for that command on our class. So let's change that. First of all, we want to say that this is an aggregate, and that makes it discoverable by Spring. So we run this application as a Spring Boot application. Axon, through Spring configuration, will automatically detect these aggregates and set up the necessary infrastructure to be able to use it at runtime. It's not absolutely necessary for the test, but it's a good practice to do. So we need an aggregate identifier, private. That's the only mandatory field that Axon enforces. Some way to uniquely identify this chat room. And then we can create command handlers. And this command handler is a constructor, because this is the command where we want to create a new room. Now, if you use event sourcing, it's very important to separate the decision making from the state changes, because we don't want to make decisions based on things that have happened in the past. So when we reload a chat room based off of the events that happened in the past, which is the essence of event sourcing, we want to be sure not to make any decisions. However, when we create a new room in this case, or send a command to a chat room, we want to validate whether it makes sense to execute such a command at this moment, this point in time. And if it is a sensible operation to do at this time, we want to decide what happens. So in the case of a constructor, is rather simple. There's no state to begin with. So the only thing we can do is validate based on the incoming command. We don't have any special business rules at the moment in this use case, so we can just apply an event. And we import the aggregate lifecycle apply method, and we apply a new room created event, and we take the room ID and the name from the command. The apply method does two things. First of all, it invokes the event handlers on this chat room instance, which take care of the state changes. And secondly, it will schedule that event for publication, so that other components outside of this aggregate somewhere, and they might be in the same application, or as we see later on, they could be distributed as well. So these other components will also receive this event. Now, we do have a state change that we want to apply based off of this event, which is setting the room identifier. And I'll show in a second why you do not want this logic to be in the command handler. Room created event, and then we set room ID is event dot get room ID. So now what happens is when we apply this room created event, Axon will invoke this method, which will set the room ID and then schedule the event for publication afterwards. If we load an existing room, we will load all the events that the room has emitted in the past, and the first one is the room created event, which will then set the room identifier. If we would set the room identifier in this method, which is a somewhat more natural way for most of us to work, then we cannot reconstruct the room ID based off of the past events anymore, which is problematic if all you have are those events from the past, which is the case when you use event sourcing. So you want to really separate the decision making, which you do in the command handler, from the state changes, which you do in the event sourcing handler. Now what Axon also needs is a default constructor. And now we should be able to run some of the tests again. And we should see one green test. Yes. So this is the one of the use cases that we have now implemented. So now we want to be able to join a room. So we have a command handler for public void handle join room command. Whoops. Now, if you want to join a room, let's take the naive approach first and say, well, we say participant, joined room event command dot. Let's double check if that is in fact the order that we expect. Yeah, so participant first room. So we say when a participant joins a room, we apply a participant joined room event. This will probably pass another test. Yes. So we have a pass test now for the test join chat room because we can now join a room. But we also see that you cannot join chat room twice. It executed successfully, but it failed on one of the assertions. And what we see now is we expected nothing, but we did get a participant joined room event. That's because we are not validating whether that participant has already joined. So note how I'm not adding any state until I have a use case that requires any state. So the name of the room is not important for any of the commands. Until now, until I discovered that the test cannot join chat room twice, test failed, we did not need the participants. But now we do have a case where we need to keep track of the participants in our room. So we're going to create some state that keeps track of the participants in the room. And of course, since we have that state, we also need to update it whenever appropriate. So we have public void on participant joined room event, and we say participants.add event.get participant. So we don't need to check whether that participant is already there. We just accept whatever is in that event. If in the past somebody did join twice, then fine, we'll just deal with it. Of course, a set is idempotent in this case, so if you add an item twice, it's in there only once. But we also want to make sure that we only raise this event when the participants didn't join yet. So if the participants dot contains the command that participant, okay, what happened? Lovely reformatting. There we go. So if it does not contain the participant, then we apply the event. If it does, we do nothing. And that's exactly the behavior we expected in this test case. So now we should have 3 passing tests. No, we don't. Now we're getting null pointer exceptions, obviously. There we go. We just initialized to an empty set. And there we go. We have 3 passing tests now. All right, so let's do the same for command handler, public void. Note that the method name doesn't really matter, so leave room command. Axon doesn't look at method names by default. So we say if participants.contains contains the command participant, then we apply new participant left room event. There we go. And of course, we have to maintain that that state correctly. So we have to create an event sourcing handler that deals with participant left room as well. And we just remove the participant. That's it. And now you can see we have 4 test cases passing. So now there's the only thing missing now is being able to post messages. So we start implementing that, and that is pretty easy to do because the chat room itself, in terms of logic, doesn't care about the messages posted. So we just have post message command, and we want to apply a new message posted event. The participant posted a message in the room, and that's the message. But we don't always want to do that, obviously. So now again, we have another case passing. There we go. And there's one missing, and that is when the room participant is gone. We don't expect an event to be published, but instead, it's saying here, I expected an illegal state exception, but it returned normally with null because it's a void method. So we want to do some assertions here. So we say if the participants, if not participants dot contains the participants that's sending it, we want to throw new illegal state exception. You must join posting. And we just throw an exception. And there you go. Now we have implemented everything that we need to handle the commands according to the specifications that we have written up front. And of course, we're good developers, so we all use test-driven development. So we all think about our test cases first and our scenarios first before implementing everything. At least that's what we say we do. Now this is all nice, and we can run an aggregate in isolation. That's not really very fancy. So we want to be able to run this as an application, right? In the end, it has to run at runtime, not at just in unit tests. And the thing missing here is we have a controller. It reacts to posts on specific APIs, and we need to send these commands on the command bus so that the chat room can actually handle them. So these are the different API functions or API endpoints that we have defined for all the commands. So we can use command gateway.send to. So the command gateway is a rather friendly API towards the command bus. So we have a create room command. Now the room ID is a bit of a challenge. I'll show you in a second. And then we have room.name. So the room ID is something that is optional in our request API, because in general, using client-generated identifiers is very useful. It promotes scalability in certain aspects, but having a JavaScript engine generate UUIDs is not very reliable. So what we do instead is we check if there is an identifier from the client, from the HTTP client. If not, we generate one ourselves. So if room get ID is null, then we choose UUID.random.toString. Oh, wrong one. And otherwise, we use the room ID from the request object. And we can actually just return whatever comes back from the command gateway. For creation commands, you get the value you get back is always a string and is the identifier of whatever object has just been created. So in this case, if it was the JavaScript client that decided what the room ID would be, it would get that ID back, and if not, it will get the server-side generated identifier as a return value. Now we do the same here. We say command gateway.send, and we return that as well. New, what is this? Posts participants we're joining. join. We're joining a room, and that is a participant dot name and a room ID. There you go. On this one, we return command send. This is posting a message, so new post message command. This is the participant, then we get the room ID, and then we get the message. So the parameters defined here, these are just Spring MVC mapping. So the room ID is taken from the path, and the post message request, that is the API as we've designed it for the HTTP endpoints. If you work with different protocols and different endpoints, you'll find out that it's actually very nice to have a different object that you would map to a command depending on the type of endpoints that you would use. And in this case, we return command gateway.send. This is not join room, new leave room command of the participant's name, and then the room ID. So now we're able to start this application and start sending commands. I'm not going to start it right away because we have view models yet to build. So now I can send commands, but I can't really see what's happening. So what I want to do instead is have a look at the projections. I'm not going to implement all three of them right away, but I'm just going to take one and then use the cheat approach to implement the others. So I'm not going to do anything that you won't be able to do based on the code base that you get from the from GitHub. So I'm going to create an event handler for this chat message projection. And this is actually the easiest projection in the sense that it doesn't need many event handlers. I believe it only needs this one. So on message posted event. So when a message is posted, we want to create a chat message entry in our view model. So this view model is focused on being able to provide the messages that have been posted in a specific chat room. So the data model that we've designed or that we use is designed for exactly that purpose. And it might not be suitable for anything else. So repository.save. So this is a Spring data JPA repository. We can just add chat message entries to it. And what it takes is a participant. It takes the room ID. It takes a message. And it takes a timestamp. Now the timestamp is not in our message posted event. And of course we could add it, but there's a reason it's not in there. There's a lot of extra parameters that you can add to your event handler methods that give you, let's say, contextual information. So Axon will wrap your event into a message, and this event becomes the payload of that message. But attached to the message, there's metadata, but there's also the timestamp. So what we can do is say we want this this timestamp, which requires an instant, which is the newest Java time API, and we want to epoch millis. No idea why. Let me turn wrapping off. There you go. So we are going to save a chat message. We're going to take the timestamp out of the message. Axon will inject that into this parameter, so we can save it as milliseconds for our database, which is the useful. So what I'm going to do now, since the scaling out is practically the solution of this first part, I'm going to cheat and look at the query models here and copy these two event handlers. I'll walk you through what they do. So this view model reacts to participants joining and leaving rooms because it keeps track of who is in what room. So basically, if we join, we add an item, and if somebody left the room, we delete by participant and room ID. And this is the Spring data JPA magic, or features, whatever you like to call it, simply because the method is called delete by participant and room ID, and we have two parameters, participant and room ID. It will be dynamically implemented at runtime to perform a delete query. Same for the find room participants by room ID. It's a way to quickly define a query. We're going to do the same now for the summary. Now, summary is a bit more elaborate in terms of the events that it is listening to. It's listening to rooms that have been created, and then when somebody joins a room, we're going to increment the counter, and when somebody leaves a room, we're going to decrement the counter. It's rather simple. We just have to load it. The saving back to the database is done automatically by JPA. So let's start our getting started application and see if everything works as expected. Usually it doesn't, but that's the fun of live coding. So the application started. I have a Postman workspace here, so I can create a room. And this room has a body, and in this case, I'm specifying the room ID explicitly because all my other requests have been prepared to use this room identifier. But I can also send a create room without any identifiers, and as you can see in the response here, we get a random UUID back, and we can send it again, and we get another ID back. So now we have a number of rooms, and we should be able to list all the rooms that we have. So this is getting the room summary. So we've created ABC 1, 2, 3, 4, which was the hard-coded one, and then we have the other rooms with random room IDs. So now we can have John join a room. We're sending a post to the participants URL. The body, there's just a name, and the room ID is encoded in the URL, and we get nothing back. We just get an ACP 200, content length 0, status 200, okay. That's it. We can send a message to the room, which should work, and 400 bad request, and we made a mistake somewhere. Send a message to a room, may not be empty, okay. Let's see why. Message, hello there. This is always good fun. Participant is empty. It shouldn't be empty. Ah, there we go. So we send participant John, and now we have a 200 okay, and we have no data. So we send a message, and we can have John leave again. That's okay. We can leave him again, and again, and again, and it's still 200 okay, even though nothing should happen to that room. So let's leave a few times, and then we send a message again. And now we get an error 500. You must join a room before posting. This is exactly the exception that we threw on the server side. So now I can get the participants. It's an empty list. And we can get the messages in that room, and we see that there's this one message posted by John in the past before he left. Now then there's this let's say somewhat technical API that we've created that just renders all of the events that have been registered for this room ABC 1, 2, 3, 4, and you can see here that there's a lot more data. So this is the actual payload. This is actually the object that we have published. And you can see that Axon adds extra information. It adds a timestamp. When was this event published? there's the aggregate identifier, which is taken from the field that we annotated with @aggregate identifier, and there's a sequence number. And the sequence number is very important in event sourcing, because when you replay past events, you want to replay them in the order they were originally published, especially since an aggregate is a concurrency boundary, a consistency boundary, sorry. You want to make sure that everything within the boundary is consistent, and the sequence number helps us guarantee that. So you can see that the room was created, then a participant called John joined, then he posted a message, and then he left the room. And remember, I pressed leave room many times, but we don't see any of those because we've decided not to raise any events in that case. So we have a pretty clean log here of what has been going on. So now we have an application, and we're all happy. We can deploy our first version. These are the exceptions that we caused by not being in a room when posting. We have an application, and great, we can go into production. And we all know that production is a slightly different environment than local, the local host. So in production, we want to be able to scale out. So we have an application now that consists of 4 main components. One is the aggregate. It receives commands and sends out events, and 3 other components that take events and update these view models. Now, at the moment, everything runs in the same transaction. So when a transaction is started to handle a command, that same transaction will also handle all these events, and we can change that. So to have more control over how we handle these projections, it's good to assign these handlers to a processing group with a clearly defined name. This one is called summary. If you don't specify this, the package name is the group that is assigned by default. But these are not very nice names to type, especially not in a hands-on webinar. So we're going to create some short names. Participant. And the last one is processing group messages. So Axon doesn't invoke these handlers directly. There's a mechanism in between that is responsible for, let's say, dealing with the technical aspects of handling a message. Now I want to show a few different use cases. One is to read messages from RabbitMQ, and one is to use a so-called tracking processor. And a tracking processor is a processor that uses its own thread to read messages from the event store at its own pace, so as fast as it can, and forward those messages to the event handler. So effectively, you're doing asynchronous event handling, but in a very reliable way, because the tracking processor keeps track of where it left off using tokens, and it stores those tokens to remember where which event it has processed last. So if there's a crash and it needs to recover, it knows exactly which messages have been processed and which haven't, and it can continue processing from there. So to make let's say the messages, that's the one that we expect a lot of events from. Let's make that a tracking processor. So one thing we can do is axon.eventhandling.processors, and we say the messages one, it has a mode of tracking. So this is one way to define the processor for the messages to be a tracking processor. And this is why it's also useful not to have the package name, because with all those periods in between the package elements, it confuses the Spring autocomplete a lot. So as soon as there's a dot in here, Spring doesn't know what properties you're mapping to. It will work at runtime, but the autocomplete isn't flexible enough to be able to deal with it. So now we have our messages. So actually, this is the way we say these events. They're now running in tracking mode. So we should be able to run this application. I have to run this scaling out version now. It needs to compile that. Let's see what happens. Yeah, I need to, because of the scalability features, we need to start a database. I'm going to start an in-memory database, but in a separate process. That allows me to start and stop applications without losing my in-memory database. There we go. Now there is a fetch token here, and this line is what the tracking processor is logging to say, hey, I've got a token. It's null because it has never fetched any events before, but at least it claimed that token and it started. So now it started processing. So now we can create a room again. So it was an in-memory database, so everything is empty again. We can create a room. Now we can list all rooms, and we'll see that the room is there. We can show all these events, and the events are still being processed. Now we can stop and restart this application. Now we should see that fetch token line again, but then not with null, but something else, because it found out that still fetching null. Why is that? That's always interesting. It's empty. Why is it empty? Chat scaling out. Update. It should not, for some reason. Okay, that's interesting. I wasn't expecting it to clear all the data again. Fetch token null. Fantastic. So you'll have to trust me that it did work before, which is really weird why it's not. Spring.tpa. It should update. Okay. Let's disable this to make sure. So that's some magic in Spring Boot that when it detects token entry not found. Okay, let's do create. When it detects you're using an in-memory database, it will recreate all the tables and drop them automatically. But that's exactly not the behavior we want right now. Let's see what happens when we restart. Oh, should have sent a command. There we go. We create a room, restart again. Where is my fetch token? Okay, it's still, I'm clueless as to why this is happening at the moment. Anyway, let's move on. Normally, if you wouldn't delete, if for some reason it wouldn't delete the database, the tracking processor would continue on where it left off. So now for the other thing that we can do, we can read messages for a processor from a different source. So by default, it will look at the event bus, which in Axon 3 is the same as the event store if you have an event store. But let's do the participants .mode .source. Let's change it to a different source, and let's choose the participant events source. So this is the name of a bean that we need to define, and I'm going to copy paste this from the solutions branch. So we can go to our application, and I create an internal class here. I'll describe what I copy pasted in a second. So we need to add some dependencies first. AMQP is not on the class path, so we need to add a dependency for Axon AMQP. Oops, 3.1. Not sure if that gives us Rabbit as well. No, we need Spring AMQP as well. Dependency Spring Boot Starter AMQP. There we go. There we go. Now we can import these classes. Make sure to import the right ones. The Spring. So this is all Spring configuration to define the AMQP queues that we want. So we have an exchange called events. We have a participants event queue called participants events, and then we bind that exchange to the queue so that all messages sent to that exchange are received on this queue. And then lastly, and this is an Axon class, we define a bean, which is a Spring AMQP message source. And this is a sort of a trick that you can do. You create a subclass of it, an anonymous subclass. That needs to import everything. And we annotate the onMessage method with a Rabbit listener. And this is again a Spring Spring annotation that says invoke this method when a message is received on this queue. And I want to run this in exclusive mode. And exclusive mode means that only one client can be connected to that queue at any time. So if an exclusive consumer is connected, no one else can connect. And if anyone else is connected, this consumer will refuse the connection. So this allows us to have two nodes looking at the same queue, but only one of them is actually processing events, which gives us the ordering guarantees, etc. If you don't want that, if you want concurrent processing, which in some cases makes much more sense, then you remove the exclusive is true, and then any node can connect concurrently. So this is the bean name that we need to specify here as a source for this processor. I have AMQP running in the background, and one thing missing is we're not publishing any events to that specific exchange, and that can be again done with a single line of configuration. We can say we have an exchange called events. Not sure if that was the name we chose. Yes, there's a fan out exchange called events, and we want to publish our events to that exchange. And if you just want to use the defaults, then this is the only line of configuration that you need to be able to do that. Let's see what happens in the background. So I should be able to go to localhost and we should see queues. We see participant events, and it has 0 events. And let's try to send a chat room. Within a few seconds, we should see that it's been. Oh, there we go. Message rates. So there was a message. So that has not been queued because it's too fast in processing. But we see that messages have been put on the queue and have been consumed on the other side as well. So now we can start another application, and it will try to start reading from that queue as well, and it will fail connecting because the queue was exclusive. There you go. So now we get these warnings because it failed to consume. Yes, it is generating some log pollution here, but that's probably configurable on the Spring side. But it's retrying every couple of seconds, and at intervals also configurable in Spring. But as soon as we stop this application, this one will stop complaining about not being able to consume. There you go. So now this one is consuming. Of course, my commands here will now fail because it's not running on 8080, but on 8081. But that's also not what we want. We don't want that one node that we're targeting to handle all the commands. So we want to be distributing our commands as well. So let's do that. Let's define that we want to use a distributed command bus instead of a regular one. So what we can do is we use the JGroups Spring Boot starter instead. This gives us all the dependencies that we need to use the JGroups-based distributed command bus. By enabling this starter, we don't get that distributed command bus automatically. We have to define a distributed enabled is true. It's false by default because it's pretty dangerous just to assume that you wanted to use a distributed command bus if Axon detects JGroups on the class path. So we want to say explicitly we want to distribute this this event, these commands. What we also want to do is we want to set the bind. Where is it? Bind address. There you go. Bind address not to global, but let's stick to my local host for now. Now this service utility class now should detect that I have JGroups on my class path, and what it will do is not only start the embedded database, but also start a gossip router. There you go. And the gossip router is one of the discovery mechanisms that JGroups can use. It's a way for nodes, when they come up, they register themselves with a gossip router, and the gossip router will tell them which other nodes are around. Typical gossip. So it's running on the default gossip port. And Axon, if you don't define a gossip URL or gossip host, it will assume the default. So gossip hosts, as you can see here, the default is localhost on port 12,001. We don't have to change anything there, so we can now start an application. And I forgot to add a bit of logging so we can actually see where. Let's do the create room. So logger.info created a room. So we add some logging, created a room. Let's do join the room as well. command.get participant. There we go. And let's do leave a room. And post a message. There we go. Restart. So here in the logging, you can see that Axon is, or the node is connecting to a JGroups cluster. It says local segment joined. It didn't detect any other nodes. It's just sending broadcasting my membership, the information that this node has. And we can now start another node. So this other launch configuration is configured to start on a different port. But still on my local machine. And this node should, it says here, latitude joined. So it's detecting the other node joining, which failed to get the connection to the queue. So now what we can do is we can create this room. And ABC1234 was handled on 8080. Now let's create a random one, still on that node. The second one wasn't generated there, it was generated here. So you can see here, created room. So that command, even though it was sent to 8080, that node decided, oh, the other node should be doing that. So when we post a message to, let's send a message into a room. We join the room as John. That is also handled on this one because that specific room ID lives on the 8080 machine. So all commands for that room will be routed to that machine as long as that machine is alive. Even if we send a message to the other node, which runs on 8081, and of course we have to change our header again, participant. There we go. Pretty sure that should be named then. There you go. So now it's okay. So we can send a message to 8081, and still the message is handled on 8080. So both nodes have a good view of which projection is running where. But the tracking processor is only active on one of the machines because by default, the tracking processor, so our, let me double check which one we have created. The messages one is using its own thread to track events. And by default, you will have one thread active at any point in time. So only one of the nodes will be processing these events. And we can see that in the H2 console. If we run this code, we can see that for the processor name messages, there's one segment, as we call it, and it's owned by this specific process ID. So that's my machine name, and this is one of the two nodes. It doesn't really matter which one, but one of them owns that segment. Now I can stop my applications. And what I can also say is I want my messages projector to use, for example, 2 threads, and the messages processor to have an initial segment count of 4. Now I can start as well. And this is a new feature of Axon 3.1 that you can have tracking processors use multiple threads. And it doesn't matter whether these threads are running on the same machine or on different machines or distributed over a vast cluster. It's all the same. Let's go back to creating some of our events, like so. So now we should see 4 tokens, and there's only one machine running, and we said 2 threads. So right now there's 2 tokens not being processed, and that's problematic. So normally you would have monitoring on this, or at least make sure that a single node is not limited to 2 threads while you say I want 4 segments. But we can now start this other application which has the same configuration. So we'll also start 2 threads, and it will claim the other two tokens. Don't worry, this is not the format of the token. This is just the rendering of the H2 console that doesn't like binary data very much. So I can start running. So for some reason, my application is clearing the database when it starts, which is not production readiness. So now the other thread, it takes a while for this node to figure out that it So deleting a message while a database while applications are running is not a wise thing to do, but for some reason that's exactly what's happening. Yeah, it's completely cleared everything, and it's now confused. So this part of the demo is unfortunately not working as we would expect. I should have used a regular database, but this is the way we define tracking processors, and this is also one of our scaling strategies. So now I can see nodes joining, so maybe there's some, no. So this could be a way to scale your applications out. Just implement these tracking processors, define how many threads you want concurrently, decide what makes sense from a single node to have as a concurrency factor if you want to execute everything in sequence or not. There's a lot more you can define. You can define in which events you expect in which order. Is there specific ordering guarantees that you need? Of course, if you need full sequential processing, then multi-threading doesn't make sense anymore. But there's always a balance somewhere between the everything in parallel or everything sequential. Usually, there's some expectations that you can set. So if we have a little look on what we just did in between the failures here and there, we've discussed application layout, so the different packages and how you can separate. So let's say the core API, which is your commands and events, and separate that from your command model. We've looked at the test fixtures, how you can use given, when, then style tests to just describe the exact behavior you have for an aggregate, and then implement that and use it as a am I done kind of progress bar. We've implemented an aggregate with the command handlers and using event sourcing, so not storing the aggregate state itself, but just using the past events completely in the background. You don't have to program anything for it. We have implemented view models, which are very data focused, so they're much less focused on behavior and much more on what data do we need to serve. And then we have configured processors for them using some annotations and property files. We've used a distributed command bus, so by adding JGroups, the Spring Boot starter JGroups, Axon will give us, or Axon in combination with Spring Boot will automatically give us a JGroups-based distributed command bus, which has a lot of configuration features. If you're for the case you're not running everything on a local host, and we have seen a fair attempt to getting multi-node tracking processors up and running. I will start to figure out what went wrong and post that one property that's probably missing in the Q&A that we will publish later on when publishing this recording. So if you want more of this, we have a public training coming on. That's actually next week. So if you're capable of joining us, there's still a few seats available for that training. It's the advanced features of Axon Framework. It's especially recommended if you have already some Axon experience. And we'll show you how to scale an application and make sure it runs reliably. So not, as you see, not all the defaults are always as reliable as you would hope. We also give in-house trainings just in case you can't make it to the Axonic headquarters next week. Just contact us and we'll be happy to give you any details. And also, if you want to know more about case studies or how other people have used Axon or what our plans are for the future, the conference recordings of the Axonic conference of last September are available in our YouTube channel. You can go to our website to find them, or just Google for YouTube Axonic, and it will. The first link is the YouTube channel for our videos. And that brings us to Q&A. So you have probably sent a few questions to our moderator, and I'll ask Eliska to read some out for me.